So today we are learning about, we're on lesson, I smushed the two lessons together, 10.5 and 10.6. It's about symmetry. And symmetry is probably one of my most favorite lessons that you get to learn all year because I feel like you can use it in so many different things. So I just put the little definition of what line symmetry is. It can be folded along a line or about a line so that two parts match exactly. And then a fold line or a line of symmetry divides a shape into two parts that are the same size and the same shape. So remember that you can fold it any way you want. You can fold it diagonally, horizontally, vertically, and to determine if the parts match exactly. So it says repeat the steps for each polygon shown on the table. So you want to think how many lines of symmetry or the number of sides tells you the number, the amount of lines of symmetry. So if a triangle has 3 sides, it has 3 lines of symmetry. If a square has 4 sides, it has 4 lines of symmetry. If a parallelogram has 4 sides, this one doesn't follow the rule because it likes to be silly. It only has 2 ways that it can be folded so that you have lines of symmetry. So only this way and this way. Since it's on a diagonal, it's difficult that way. But any typical figure, square, triangle, anything like that, the amount of sides equals the amount of lines of symmetry. A rhombus has 4 sides, and this is the same as a parallelogram. It's tilted, so it only has 2 ways that it can be folded in half to create symmetry. A trapezoid has 4 sides, but only has 1 line of symmetry because you can only split it down the middle. And then a hexagon has 6 sides, and this has 6 lines of symmetry. So any of the basic figures, square, triangle, hexagon, decagon, octagon, all those, the amount of sides matches the numbers of lines of symmetry. Now a circle has an infinite amount of symmetry because you can go on forever and ever and always split it in half or diagonally, and it will always have the amount of lines of symmetry. So here's a little activity that we're going to do. So it says, fold a line tracing over the vertical line. Do the 2 parts match exactly? And you're going to say no, because if I was to fold that over, this whole part would be left out. Do the 2 parts match exactly this way? No, this part would be left out. Do the 2 parts match exactly this way? And the answer is no. This one's a little bit smaller than this one, even though it might not look a little weird. So figures like this are difficult to find a line of symmetry because you have a side that sticks out and a side that's up and down. So you can never perfectly get it to be a perfect line of symmetry. So tell whether the parts on each side of the line match. Is the line a line of symmetry, right? Yes or no? So when you're going on for this one, you need to be careful because yes, it might look like it would match up exactly because they're both the same size shape, but they're placed in different areas. So imagine in your head folding a rectangle in diagonally. It's not going to match up perfectly. This side, this point, and this point would not match up perfectly. This one would be yes. Imagine folding them over. This one would be yes. The eyes would match up. The face would match up. The mouth would match up, and it's a circle. Yes. And then this one, no. The point and the bottom half are not the same size or the same shape. Moving on to the back. Tell if the blue line appears to be a line of symmetry, right? Yes or no. Circles pretty much, or ovals pretty much always have lines of symmetry. So yes, they would be the same if you fold it over. This one would be no. It looks really, really similar. But since it's on an angle, it ruins the line of symmetry because the parts or the sides don't match up exactly. Here, no. Well, first off, it's not down the middle or across or keeping the 2 sides the same length. And then this one is yes. Tell whether the shape appears to have 0 lines, 1 line, or more than 1 line of symmetry. Right, 0, 1, or more than 1. So this one is where you really need to practice cutting the shape in half or horizontally, vertically, all that kind of good stuff with your eyes. You have to envision it. So I like to draw on the paper. This one, we could go this way, and it would be the same. We could go this way. So this has more than one. This one has 0, and I'm going to tell you why. The shape of this leaf is not identical to the other side. This would never match with anything on the side. Now we have the sign dollar, or the sand dollar, I'm sorry. You can split it this way. I'm going to say 1. And then this L shape, it's a little bit different than the L we did before because guess what? Both of the sides are even. They're both the same length. So if you split it like this, they would be one side of symmetry. Practice and copy. Does the design have line symmetry? Right? Yes or no? If you answer yes, you have to draw the line of symmetry. So I'm going to say yes because guess what? Right down the middle. This one, no. Take a look. You can't nothing. You can't do anything this way, this way, this way, this way, for it to be the same side on both sides of that line. We have this like 1, 2, 3, 4, 5. We have this like hexagon shape. You can cut it down the middle. You can cut it this way. So I'm gonna say yes. And then this one is no. You can't cut this anyway for it to be the same. So the bottom is to complete the design by reflecting over the line of symmetry. So pretty much all you need to do is create the drawing or the other half of that figure on the other side of this line, this red line right here. So this one, if it goes out like this, you can create it 1, 2, 3 on the other side. And this is just 1 over, and then it goes this one, so this takes up 1, 1, 2, diagonal across 2, cut across 2, diagonal up 2, and then up. Do you see how I'm matching it up? I'm like counting the squares. This one, so you just need to make sure that this one's a little bit difficult because you have to envision cutting it in half. So you can't draw down, you have to draw across. You're going to create this part right here. So you 1, 2, 3. Oh, wait, it's this one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then you just come on down. And then this one, we have 1, 2, 3. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And we're done.